this is section 6.3. We're talking about matrices and systems. In order to solve a matrix with what we're going to call Gaussian elimination, we first start off with the augmented matrix. The augmented matrix takes the coefficients 3, 2, 2, negative 3, places them in a matrix. But what makes this matrix augmented is we put a line where the equal sign goes, and we put the corresponding constants right there. So basically, all I did was copy down the coefficients and constants. 3, 2, 6, 2, negative 3, negative 9. That's our augmented matrix. Now, our goal is to get this in row echelon form. Row echelon form looks like this. 1, 0, 1. We don't care what goes here, and we're just going to have some numbers here. So you want to get a 1 and then a 0 under it, and then you want to get a 1 here. And we can do that using any of our matrix row operations, which are going to be very similar to if we were just doing regular elimination. So, the first thing I want to do is I want to turn this 3 into a 1. How can I do that? I can multiply row 1 by 1/3. So to get this new row 1, I'm going to multiply by 1/3. So that'll be 1, 2/3, 1/3 of 6 is 2. And then I'll just keep row 2. So in other words, my new row 1, and I'm just going to put R1 for row 1. My new row 1 is equal to 1/3 times the original row 1, or the previous step, row 1. All right, so now I've done step 1. I have a 1 in the first place. Row 1, column 1. Now I want to move to the 0. You do this one, then you move to the 0. So I want to make this a 0. I can do that by multiplying the top row by negative 2 and adding them together. So I'm going to keep row 1, 1, 2/3, 2, and keep that. But to get my new row 2, I'm going to do negative 2 times the current row 1, this row 1 right here, negative 2 times the current row 1 plus the current row 2. And you might be able to do that math in your head, or you might be like me and to keep things straight, you want to write it out. So if I'm going to write this out, negative 2 times row 1 is going to be negative 2, negative 4/3, negative 4. That's your negative 2 times row 1. And then my row 2 is just 2, negative 3, negative 9. And I add those together, I get 0, which is what I was hoping for. I wanted that 0 to be there. Negative 4/3 minus 3 is going to be negative 13/3. And then this will just be negative 13. So that's going to be my new row 2. 0, negative 13/3, negative 13. All right, we've got one more step to get this completely in row echelon form, and then we can solve. We have to make that negative 13/3 equal to 1 by using one of our row operations, interchanging a row, multiplying by a non-zero constant, or adding a row to another. So what's this one going to be? To make this into a 1, what should we do? We should just multiply by negative 3/13. So our new row 2 is going to be negative 3 over 13 times row 2, which will give us 1, 2/3, 2, 0, 1, negative 3. And we now have it in row echelon form. Is this reduced? Is this reduced row echelon form? No. If you wanted to make it reduced row echelon form, you could always multiply row 2 by negative 2/3 and add it to this row, and you'd be done. Okay? If you wanted to make it reduced row echelon form, you could get a new row 1 and make this 0 by multiplying this by negative 2/3 and adding them together. But I don't need to do that because now I can just solve. I can say, all right, this is my x column. This is my y column. So if I look at the last line, I can see that 0x, which I don't write 0x, it's just 0, plus 1y equals negative 3. This right here tells me that y equals negative 3. And then I can go back up to the first line that tells me, this right here tells me that x plus 2/3 y equals 2. This is the x column, this is the y column, so x plus 2/3 y equals 2. And I plug in the negative 3. So that's going to give me x minus 2 equals 2, so x is 4. So your final answer is 4, negative 3. How could you check yourself? Go back to the original 2 equations and plug in. Alright, so now we're going to use elimination to solve this system of 3 variables with 3 equations. I'm going to start with my augmented matrix, 2, negative 1, 4, negative 3, 1, negative 2, negative 10, negative 6, 3. Since there is nothing for y, good. And then 4, 7. That's my augmented matrix. That's one you should not miss. That's the easy part. The augmented matrix. Now I'm going to use my row operations to get it in this form. Remember, I want to have 1s on the main diagonal, 0s underneath the 1s, and I don't really care what goes here.
Is this recording your voice too?
Yes. Okay.
You can get the middle one up at the top.
Good. Okay, so we're going to use those same row operations we used with the two variable system, and we're going to move this 1 up here. So basically, I'm just going to interchange these 2 rows because my goal is to start with this 1 and get 0s underneath it. So I'm going to have 1, negative 2, negative 10, negative 6 as my first row. Then 2, negative 1, 4, negative 3, 3, 0, 4, 7. And I did that by interchanging row 1 and 2. So I interchanged row 1 and row 2. Now, I would like to get 0s underneath it. I'm going to get 0s underneath that 1. So I'm going to need to multiply row 1 by what to get rid of this 2? I'm going to need to multiply it by negative 2. So I'm going to say that the new row 2 is negative 2 times row 1 plus the current row 2. So that'll be multiplying this top row by negative 2. I'll have negative 2, 4, 20, 12. And then my original row 2, 2, negative 1, 4, negative 3. Remember, this was the negative 2 times the current row 1. There's our row 2. We're going to have a new row 2. So that's going to be 0, 3, 24, 9. So we're going to keep row 1. Our new row 2 will be 0, 3, 24, 9. We're going to work on row 3 kind of the same way that we did row 2. All right, so row 3 begins with a 3. What number do we want this to be? 0. So we can multiply row 1, multiply this row 1 by -3 and add them together. So the new row 3 will be -3 times row 1 plus row 3. -3 times row 1 plus row 3. And that's going to give you the new row 3. So that'll be -3, 6, 30, 18, and then 3, 0, 4, 3, 0, 4, 7. Oh, I'm not changing anything there. And so now we'll have 0, 6, 34, 25. All right, so the next thing we're going to do is move to row 2. The 0 is in the correct space, but this needs to be a 1. How are we going to make this a 1? We're going to multiply row 2 by 1/3. So we're going to do, I'm just going to write a shorthand here. 1/3 times row 2. So I'm going to keep 1, -2, -10, -6. But I'm going to multiply row 2 by 1/3. So, well, that'll be 1/3 times 0, 3, 24, 9. So that'll be 0, 1, 8, 3. I'm going to go ahead and do my new row 3 while I'm here. Row 3 already has a 0 here. That's good. What do we want to be here? A 0. How can I get rid of the 6 that's there? I can multiply it by this new row 2. Okay? So I'm going to do -6. So the new row 3 is -6 times row 2 plus row 3. So -6 times row 2 plus row 3 is going to give me the new row 3. So that'll be -6 times row 2 will be 0, -6, -48. I lost my place. -6, -48, -18. And then the row 3 that I'm referring to is this row 3, 0, 6, 34, 25. So my new row 3 is 0, 0, -14. What does this number come out to be? 7. Okay, thank you. So 0, 0, -14, 7. I feel like fatigue is setting in. Is it setting in for y'all?
34.
I'm telling you, fatigue sets in after you've looked at arrays of numbers for so long. And the last step, the very, very last step to getting this in row echelon form, we want to make that into a what? So we're going to multiply by what? We're going to multiply by -1/14. I moved up a little too much. So we're going to say our new row 3 equals negative 1/14 times the current row 3. Keep everything else. So that'll be 1, -2, -10, -6, 0, 1, 8, 3, 0, 0, 1, -1/2. Woo! Finally, we are in row echelon form. Now that we've got it in row echelon form, I can start by using this last piece of information. The last line tells me that z is negative 1/2. The last line tells me that z is equal to negative 1/2. Row 2 tells me that 0x plus 1y plus 8z equals 3. So I'll write y plus 8z equals 3, and I'll plug in that negative 1/2. So y plus 8 times negative 1/2 equals 3, and when you work that out, you get y is 7. So we know that z is negative 1/2, and we know that y is 7. Make that look more like a negative 1/2. So lastly, we can use row 1, which tells us that x minus 2y minus 10z equals negative 6. So x minus 2y minus 10z equals negative 6. And we will plug in 7, or substitute, 7 for y, negative 1/2 for z, and solve for x. So x minus 14, negative 1/2 keeps looking like a positive 1/2, y'all. That's a negative. Plus 5 equals negative 6. So we get that x equals 3. So our final solution, the solution to your problem, is 3, 7, negative 1/2. X, Y,